Video 2.1 Essential Variables. The heat affected zone is where this whole thing starts with essential variables. The liquid weld metal gets deposited, it solidifies. We've got the heat affected zone, and then we've got the base metal. So essential variables are ones that if we change them, it's going to affect the mechanical properties of our deposited weld metal and our heat affected zone. So this is where this whole thing starts with essential variables. So if we change one of these variables, it's going to affect the mechanical properties of the heat affected zone and the base metal and the weld metal. This is an example of like some tests that are done. This was I cut out of somewhere that I did something. But you can see where this would be taking micro hardness tests across a base material, unaffected base material, heat affected zone, and the weld metal. So this is kind of giving you an idea that this is relatively important in welding. So when we're talking about these variables, we're talking about an essential variable. So that when we change this outside its range, we're going to have to requalify. And that's because we've changed the mechanical properties of the base metal, weld metal, or heat affected zone. And while we're here, we might as well touch base on non-essential variables. These are things that if we change, it's not going to require requalification because it doesn't affect our mechanical properties, our strength, our hardness, our ductility of our base metal or heat affected zone or our weld metal. A supplementary essential variable, we're talking about impact testing. And this is a Sharpie impact test right there. So if we're talking about changing a variable that is going to affect our impact strength of our material, it becomes an essential variable. This is another formation point. This is what a weld test coupon looks like. This is kind of generic. I don't know if I got it from some DOT, Department of Transportation site or a U.S. military site. But anyways, this is how they're all pretty much the same. This is how when we qualify welds, we put weld metal into a weld joint and then we cut it up and we do some mechanical testing on it. And here we're circling back around. This is ASME Section 9. This is where it tells you what an essential variable is. Affect the mechanical properties in the weldment and shall require requalification. And then we have supplementary essential variables. This is notch toughness, impact testing. And then non-essential variables, those would be things when we change them, it doesn't affect things. And then an example like that would be using a certain type of wire brush when you're welding. That would be an example of a non-essential variable. Maybe we have a customer that wants their welds cleaned only with some type of magical stainless steel wire brush. And I know that's an absurdist example, but let's say that's what they want. Okay, we have to do it that way. We have to give our welders work instructions not to use regular carbon steel brushes, but to use the magical stainless steel wire brushes. We haven't affected the strength or the mechanical properties of the weld metal or the base metal or the weldment in general, so we just have to list it. This is also out of ASME Section 9. We don't have to do it on a weld test plate. We can do it on a piece of pipe. We can use it on, use another form when we qualify our welding procedure. We can use, forgings, castings, tubing, pipe, plate, whatever. But this would be an example. I think I snagged this one out of a military manual also. But it gives you a really good idea of where we would be taking our mechanical destructive samples from, our bend tests and our tensile tests. Here's the mechanical destructive tests that are required by ASME Section 9. You can see we've got tensile tests up in the upper left-hand corner, and you cut these out of the test coupon, and you have them machined or ground down to a specific size, and then you pull them apart and you measure the amount of force. So that tells us the tensile strength on that weldment. And then you can see we've got guided bend tests. This is going to test the ductility. Is this thing going to bend, or is it going to shatter on us? Is it a super hard material? What do we got going on? And then there in the lower right-hand corner, that's some Sharpie impact testing. And that's going to tell us how much of a beating a piece of material can take at a certain temperature. Here's an example of what tensile tests look like. Generally, we take them perpendicular from the weld. We can take them parallel to the weld, but we just make these samples and we pull them apart and we measure how much force it took to cause these things to fail, to pull apart. We measure that and we compare it against the code requirements, and it either passes or fails. So why do we care about this? Well, the mechanical bend test, like bend tests, these are simple. You cut a piece of metal out of a weld and you bend it. And if it doesn't come apart, break, or have too many defects on it, it's going to pass. It's going to tell you that the weldment has enough ductility, and our welding procedure is going to be solid, and we can go forward. We use these for butt welded tests, butt welded coupons. The equipment's cheap and relatively simple, and the samples, we just slice samples out of there, bend them, polish them a little bit, look at them and see what's going on. And here we're circling back and looking at the heat affected zone once again, and the weld metal and the unaffected base metal. So you can see how this could be problematic if we change the filler material or we change some variable that is going to cause us to have different results in our heat affected zone as far as mechanical properties, or our weld metal, or in that base metal. So here's some examples of essential variables. Here's one, post-weld heat treat. Obviously, if we're post-weld heat treating, we're going to throw some thermal energy into that weld metal and the heat affected zone, and it's going to change it. It's going to stress relieve it probably. It's going to give us a different tensile strength and a different ductility than it would have in the as welded condition. And when I say as welded, we weld it, and when we're done welding, we don't do anything with it. It's done. Well, sometimes we have to post-weld heat treat something, and we weld it up, and then after we're done welding it up, we send it somewhere, or we cook it in place like we've got right here. Another essential variable would be thickness qualified. Well, with the thickness qualified, our heat affected zone and our weld metal are going to be different thicknesses. So we're going to put different amounts of thermal energy, heat, into the base metal, and it's going to give us different mechanical properties. The odds are that that thin material, if we weld that up, it's going to cool very quickly. And it might have different mechanical properties than a thicker piece of material. So that's why the code has thickness qualified ranges for materials that we weld up. So you don't just weld up a really thin test coupon and then you're qualified to weld, an 8-inch thick piece of material. Or you weld the 8-inch thick piece of material, now you can weld on something that is essentially sheet metal or a beer can. So the code has this built in there because you're going to have different mechanical properties in thin materials and thick materials when you weld them up. Even though you're using the exact same filler material, the exact same voltage, amperage, whatever, the code and the people that write the code realize that there's going to be some mechanical property differences between thick welds and thin welds in the same material. Here's another example where we would have a difference, and this would be in the base metal or in the weld metal itself. And we might be using the same tensile strength. Well, this example, we're going from a 60,000 tensile strength material to a 70,000 tensile strength material. Well, obviously that's going to give us different mechanical properties. Or let's say this was, the top one was 7010 and had the exact same tensile strength as the 7018 below. They would both have 70,000 pound tensile strengths, but their usability, the F number there, even though the A number says that the same chemistry is happening in the deposited weld metal, the F number is different. The usability, F3 material is a little bit easier to use than F4 material, that low hydrogen 7018 material. So we're going to have different mechanical properties in the deposited weld metal, even if we're using the exact same tensile strength material. They're going to go in there different. So the code says this is an essential variable. Where do we find our essential variables? Well, all codes, most codes, are going to have a list of essential variables. And this one's out of QW 256. This is out of ASME Section 9, American Society of Mechanical Engineers, Section 9. And each welding process has one of these tables like this. So you can see this one is for gas tungsten arc welding. You can see we've got our essential, supplementary essential, and non-essential variables. And when we're qualifying a procedure, we have to address all the essential variables. This is a procedure qualification record, also known as a PQR. So the right-hand side is where we're going to put all our data that we get back from the lab when we send our test coupon out for destructive testing. It's going to tell us, hey, our bend tests, our guided bend tests, they passed. Maybe we did some toughness testing, some impact testing, and we're going to put that data there. And then we're going to put some data in the tensile test form table up there. And then on that left-hand page, that's where we're going to record all of our variables that are essential variables. We're going to list all of that. It might be a range. It might be a single number. We might have done something at 12.4 volts, or we might have done something at 12.1 to 13.4. You write down whatever you've got, whatever you recorded. Was it a single number? Was it a range? But we record all that information on the procedure qualification record. You can also put on non-essential variables into this form if you would like, but it's not required. And once again, if you don't want to use this form, make up your own or get a different kind. And this is what a WPS looks like. So on the WPS, we're also going to put our essential variables, and we're also going to list our non-essential variables. WPS, as I've said before, is a work instruction. You are trying to set your welder up to have success, to be successful. So our WPS, our welding procedure specification, is a work instruction. And on this, we list all our essential and non-essential variables.